Review. Valid logical statements. A logical statement is valid if it is always true regardless of the truth values of its component parts. To test the validity of a compound statement, construct a truth table to analyze all possible outcomes. If the last column, representing the complete statement, contains only true values, the statement is valid. We need this definition for our next two examples. Example, truth tables number 8. Create a truth table to determine if the following compound statement is valid. Parentheses, P and Q, close parentheses, implies P. Once again, we have two columns given to us. They are labeled P and Q with values of true, 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 false, false, true, false, false. Now our third column needs to be the statement P and Q because we need to know the truth value of P and Q to determine if P and Q implies P. So that will be our completed statement is parentheses P and Q, close parentheses, implies P. Now we can look at the columns labeled P and Q and apply the rule of AND to that, which is when both P and Q are true, that statement P and Q is true, and every other case is false. So that makes this column true, false, false, false. For our final column, we need to compare the columns P and Q with the column labeled P. And in this case, the premise is P and Q. That's important. So when my premise is true, but my conclusion is false, then the conditional is false. Otherwise, it is true. So the first one I have, if true, then true, which is true. If false, then true, that's true. If false, then false, that's true. If false, then false, that is also true. So the question is this statement valid? And the answer is yes. This statement is valid because all of that last column, all it contains is true. Example, truth tables number 9. Create a truth table to determine if the following compound statement is valid. Parentheses, P or Q, close parentheses, implies Q. So once again, we have the two columns labeled P and Q given to us as true, 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 false, false, true, false, false. Now the column headers that build to our completed statement will be P or Q. In the third column, in the fourth column, the entire statement, parentheses, P or Q, close parentheses, implies Q. So we'll look at the columns labeled P and Q respectively and apply the rule of OR to them, which is if there is a true in either of those cases, either of those columns in that row, then the result is true. So true or true is true. True or false is true. False or true is true. False or false is false. So the third column labeled P or Q is true, 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 false. For the final column, we will look at the P or Q column and the Q column. P or Q is our premise, and Q is our conclusion. So we will compare those two and use the rule of the conditional. So we have, for the first row, true implies true, true. Second row, true implies false, false. Third row, true implies true, true. Fourth row, false implies false, true. So that last column for the completed statement is true, false, true, true. Now, is this statement valid? And the answer is no, it is not valid because that last column contains a false in it somewhere.